Dear students, today we have to discuss about the Oersted's experiment. In the year 1820, Oersted said that whenever a conductor carrying a current it gives the effect upon a magnet, and in 1820 he gave a simple experiment how a current carrying conductor is affected upon a magnet. So dear students, this is a conductor AB, and that conductor is directly connected with a battery with the help of a key. And a magnetic needle having two poles, south pole and north pole. That magnetic needle is very close to the conducting wire and which is parallel to the conducting wire. When the key is open, means not closed, there is no charge will be flow from the battery, and at that time the magnetic needle is not deflected as shown in figure 1. Now in figure 2 the key is closed. While the key is closed, some amount of charge is flow from the battery towards the conducting wire. Flow of charge means some amount of current is passed through the conducting wire. At that time, Oersted observed that the direction of needle is deflected. He observed that the magnetic needle is deflected from its initial position. In first case, it is parallel to the conducting wire, but in second case, it is not parallel to the conducting wire, and that magnetic needle is deflected. And he says that when there is no charge upon the conductor or there is no current upon the conductor, it does not affect upon the magnetic needle. But when there is a current upon the conductor, it deflects the magnetic needle. And he concludes that a wire carrying conductor always create a magnetic field around it. Now, if we give a high voltage battery, then more amount of current will be passed. Again, he observed that when more amount of current will be passed from the battery towards the conductor, the needle is deflected quickly, and it is also more deflected. That means the deflection of the needle is increases. Again, he says that when the amount of current is increases more and more, the deflection of the needle is also increases. Then after Oersted change the position of the battery, means the positive at initially he take positive negative, Now change the position of the battery, that is negative and positive. After closing the key, now the direction of current is in opposite direction along the conducting wire. And he observed that the deflection of the needle is also opposite as in previous case. पूर्व केस रे जो पट को डिफ्लेक्शन होता बर्तमान कौन हो तार अपोजिट केस रे डिफ्लेक्शन स्टार्ट होगा एंड इफ वी गिव मोर एंड मोर अमाउंट ऑफ चार्ज टुवर्ड्स द कंडक्टिंग वायर द डिफ्लेक्शन ऑफ द वायर इज आल्सो इंक्रीजेस. So from this experiment we conclude that whenever a conducting wire carrying some current, it must be effect upon the magnet, and that moving charge is effect upon the magnet. When the wire AB is held at right angle over the needle, जदि इ नीडल ऊपर व्हाइट आम इमित रखिया राइट एंगल, दिस इज द नीडल, दिस इज द नीडल. इ नीडल ऊपर जो व्हाइट आम एमती लंब भाव रखिया, व्हेन द वायर इज हेल्ड perpendicular to the needle means right angle over the needle is not deflected at all, which shows that magnetic field of current is right angle to it. जितल कि मैग्नेट उपरे कंडक्टिंग वायरटा राइट एंगल भाव में रखा जाए ए टाइप जदि आम रखा तेबे द मैग्नेट डज नॉट डिफ्लेक्ट एट ऑल एंड द मैग्नेटिक फील्ड कंसिस्ट ऑफ द लाइन्स ऑफ फोर्स which forms complete circles around the conductor. For example, if this is a conductor and the magnet is parallel to the conductor, भाविनियो एतिक डिस्टेंस पर्यंत से इफेक्ट पकेला जो द्वारा कि इट इज डिफ्लेक्टेड होची. जदि एपटे 3 सेंटीमीटर से डिफ्लेक्ट हैला, एटा तमरो व्हाइटटा एपटे जदि 3 सेंटीमीटर हैला, एपटे 3 एपटे 3 एपटे 3 चारिआडे से 3 सेंटीमीटर इफेक्ट हो गयो. सो यू गेट a circular path and it is called as a concentric circles around the concentric circles. Now what are the conclusions from the Oersted experiment? The first conclusion is that a current carrying conductor produces a magnetic field. Second one, the larger is the value of current in the conductor, the stronger is the magnetic field and vice versa. अत्यधिक परिमाण जदि आम करंट दबा तो मैग्नेटिक फील्ड स्ट्रांग हम. द मैग्नेटिक फील्ड प्रोड्यूसड बाय करंट कैरिंग कंडक्टर इज राइट एंगल टू इट. मैग्नेटिक फील्ड इज ऑलवेज राइट एंगल टू द कंडक्टर. कौन पाई देख इटा है तुम कंडक्टिंग वायर आर चतुर्पार्श्व तुम मैग्नेटिक फील्ड तैयारी होची. इ मैग्नेटिक फील्ड रो सरफेसटा इ कंडक्टर प्रति ऑलवेज राइट एंगल. A current carrying conductor produces a magnetic field consists of circular lines of force concentric with conductor. अनेक गुड़े circular line दबो. A charge whether stationary or in motion produces an electric field around it. If the charge is in motion, in addition to electric field, it also produces a magnetic field. It means when the charge is at rest, Q is at rest, it produces only electric field. But when the charge is in motion, it produces both electric field as well as magnetic field. Now another new topic, what do you mean by current element? Current element is a vector quantity and whose magnitude is equal to the product of current and length of the small element having the direction of the flow of the current. For example, this is a conductor AB and that conductor AB carry I amount of current. From the conductor AB, we have to choose a small element having length dl. So no doubt, dear students, the small length dl also carry high amount of current, and the direction of flow of current is from A to B. It has a particular direction and it has a specific magnitude of electric current. That's why it is a vector quantity. So what do you mean by current element? The product of current and the small element dl. This product is called as current element, and it is always a vector quantity. So current element is equal to I into dl. This is a simple experiment given by Oersted, and from this experiment we conclude a current carrying conductor always create a magnetic field around it.